back. Oh, so far. We just want to get started. Okay. I did very well because the name is behind me. Carsten has been introduced already for people who haven't been here before. Both have quite a lot in common, I have to confess. They are totally separate at the same time. So Carsten is with Adobe, and David is with Red Hat. Both are senior developers, I would say, principal, senior. So from that perspective, that's the difference. What they have in common is, first of all, they do the presentation together. Second point is, both of them are involved in OSGI matters. David is co-chair of EG. Carsten is so kind to get involved in EG Enterprise activities as well. Both of them are alternates at the OSGI board, so both of them are also involved in strategic matters. And last but not least, both of them are very highly involved for many years in open source projects. So please welcome both of them.
Thanks, Susan, and welcome everyone to our talk about what's cool in the new and updated OSGI specifications. We had a slide about ourselves, but I mean, Susan has mentioned this already, so I'm just going to give it over to Carsten. Yeah.
Okay. So this is a fun game now. We have to pass this one over each time we switch. But on the other hand, this is a good part because when I'm talking, David can't say anything. So that's pretty good. Yeah, you're on mute. Okay, yeah. Welcome as well from my side. Now we'll start with outlining the agenda for today's talk. We will cover a lot of different specifications, so this talk is divided into smaller parts, each part covering usually one specification we are currently working on. It starts with interesting stuff in the framework, then goes over to CDI stuff, repository updates, Declarative Services, HTTP Spec, and so forth, and then goes into the more, let's say, more interesting parts, because these are then new specifications like the cloud stuff. Yeah, there are several specifications in the cloud stuff, and then we round up with various other things. This list is non-exhaustive, so we are working on additional stuff, which we won't mention today, but I think we will cover hopefully the most interesting stuff, I guess. Yes, right. So I will start with one of the additions to the framework for R6, which is named Service Scopes, RC 195. If you're familiar with the OSGI framework and the way you can register services, right now you have two choices. Either you register a singleton or you register a service on a bundle level, which means that each bundle which is using this service gets a different instance. So this is a service factory which you can register instead. And there's always been a need, especially if you look at other component frameworks, there's always a need to have something like a prototype scope. So each client of your service really gets a new instance and can work with that. That's what we named the prototype scope. And the main drivers, at least for our use cases, were other EG specifications like the EGB and CDI one, but it will be used in other specs as well. And it introduces a new strangely named interface, I think. It's the PrototypeServiceFactory. And this one basically just extends the service factory interface and acts as a marker interface. So if you're registering such a factory, this means that usually each client using this service gets a new instance. But of course, the methods are the same as for the service factories. It's just, as I said, a marker interface. And on the using side, it gets even more interesting as we needed a way to get prototype scoped services, and therefore a new method getServiceObjects has been added to the bundle context. And this gives you back a ServiceObjects object, which has a getService method, and usually with prototype scope services, each time you call getService, you get a new instance. You can also use these interfaces for singleton services and bundle services. And this means then if you call getService for a singleton, you always get back the same object, and for bundle, depending on the client bundle, you get a different instance. So this is the brand new thing in the framework, the prototype scope, which will be used in other specifications. So let's go to another topic, which is totally unrelated to that one, which is also more or less part of the framework, which is the data transfer objects. And this defines a data model for OSGI and for the most interesting parts in OSGI that allows you to serialize and deserialize the state of your current instance, like the installed bundles, their states, services, and so on. And use cases for this are different, let's say, management APIs or ways, like having a RESTful interface to your installation and get all the state information from the REST interface, or a JMX console where you can inspect your stuff, or even the web console I presented earlier on could make use of this data model, and so on. And all the other specifications we are doing usually try to define these data transfer objects as well. So for example, for the declarative services, we will have that. So yeah, it rounds up, and all the specifications are making use of that. Just to give you a brief idea of how this looks in the framework. For example, there's a bundle DTO, which gives you the current state of the bundle, like the ID when it was last modified, the state, and so on. And at least for the framework part, we are using the adapter pattern. So for example, you can adapt the bundle object to a bundle DTO. There's adapt to method on the bundle object, and then you get back the DTO. And this is used for all the other DTOs defined as a framework. So you usually get them using the adapter pattern. And just to give a rough overview over the different DTOs we have, so there's one for the framework, for all the bundles, the service references, and the different informations regarding start levels, and the capabilities, requirements, and so on. There are a lot of different DTOs defined. It's all is basically covered by DTOs, and you can inspect your installation using the DTOs and then maybe serialize the state and use it somewhere else. And with that, we're going to the next topic.
Thank you. Okay, let's talk a little bit about CDI. Not sure if everybody's familiar with CDI, but it is a very popular programming model that was originally developed for JavaEE. So it's an annotation-based injection standard, actually, that is used quite heavily in the JavaEE context. Our C193 is about bringing CDI to OSGI. And there's really two use cases for it. There's people who just really like the CDI annotations, and they want to continue to use those annotations in an OSGI context. I mean, you know, to work with components and services. So in that use case, it would really be an alternative to declarative services or Blueprint, a different programming model. It's all about choice, and there's people who want to use CDI in that context. But there's also another use case, and that's more where you already have a JavaEE system that is written using CDI, and you want to migrate your kind of static JavaEE system to a more dynamic OSGI world. maybe you want to get your injection points in CDI satisfied by OSGI services, for example. So, you know, that's a migration path that some people have, and this RFC is also useful in that context. And from a very high level, it's really about two things. It's about publishing CDI beans in the OSGI service registry, and it's about injecting OSGI services into CDI injection points. That's pretty much it. I mean, there's a lot of detail around it, but that's from a high level what this is about. So just to give you an idea what it looks like, just have some code here. If you want to publish a CDI bean as an OSGI service, you can put an extra annotation on it, an add component annotation, and that will do the trick for you. And similarly, if you want to have your CDI injection point satisfied from the OSGI service registry, you can add an extra add service annotation on top of it to achieve that. Now, there's still a bit of discussion about this because obviously this is great for new code, annotations are nice, but especially in the case where you have existing code, you want to migrate to OSGI, you may not want to touch your original source code. So there's most likely going to be an alternative mechanism to this, where instead of adding these extra annotations, you can provide this information through the manifest. So that, I mean, you can use your class files as they are, you can use your JavaEE classes as they were originally compiled, but still integrate with OSGI. But that's really all there's to it. I think this is going to be a very nice model for people who like annotations and like to work in CDI. But obviously, it's just an alternative. And the nice thing as well, because this interacts with the service registry, you can work with other things that interact with the service registry as well, like, for example, DS, which is what Carsten is going to be talking about later. It all interoperates.
One question. May I ask a question?
Yeah, sure.
Could you go back? So you have both annotation inject and add service.
Yes.
I would guess the add inject was from the former CDI.
That's the CDI
and
one.
the add service is from the Declarative Services injection.
It's not actually the Declarative Services injection, it has a different package.
Yeah.
So it's the CDI injection.
But usually you have at runtime you have only one CDI container responsible for the annotations. So would it even work if you raise the add inject and just put the add service?
It's a good question, but then it's not CDI anymore.
No, it's not.
Right.
If you migrate to OSGI.
So this is a CDI, an OSGI CDI annotation.
Okay.
If you have a pure OSGI CDI annotation, you probably also need the add inject, because without the add inject, it's not a CDI injection point anymore. If you wanted to do an add service annotation without anything else, you could use the DS annotation instead.
Sure.
And you could actually, it's not the case that there's only one injection container that has to be present, because these annotations are actually in different packages. You can combine any number of injection containers you want, and they all work through the service registry. So you can certainly mix them. But I think just to come back to your actual question, I think I can bring it up in the discussions. But I think the people who are CDI experts are going to say, well, if you remove the add inject, it's not CDI anymore. Okay, so the next topic is the OSGI repository, version 1.1. And although the original repository spec actually came out in the Enterprise R5 release in 2012, and it's actually a very nice and powerful API, but I'm not quite sure whether everybody is familiar with it. So before going into what repository 1.1 is, I'm going to be really briefly talking about what repository 1.0 is, just to get everybody up to speed. Oh, it's a bit big. Well, it's okay. So the repository API in repository 1.0 is just a client-side API to work with capabilities-based repositories. So an OSGI repository can store any kind of resource, but the special thing about it is that these resources have additional metadata, which is represented as capabilities. So if you compare it with a Maven repository, you have artifacts and you can find your artifact if you know the artifact, the group ID, the artifact ID, and the version. If you have those three pieces of information, you can find your binary artifact. There's some metadata as well, but that's kind of predefined by Maven. In OSGI, you can search for your artifacts based on your capabilities without actually having to know what your artifact is called. So it's a metadata-based search. And in its very kind of most generic form, it is here at the top. It's really, as a client, you say, I want to find a provider of capability 1. So my requirement is capability 1. You give that to the repository and it will return you the matches. So that could be more than one match, 0 too many. Another thing to mention here is that the repository, although it's kind of drawn as one database thing there, is really kind of how it's implemented. The backend is completely opaque. So you could even, and this has actually been done by Peter Kreens in his JPM4J project, you could use Maven as the store for the binaries and have another store for the metadata on the side. Or you can federate them. I mean, you can implement them in any way you like. The repository spec is really about this client-side API. So one of the kind of most obvious ways to use it is, I have a bundle that needs another bundle that exports the org.foo package in a particular version. I mean, that's a very common case in OSGI. You have a dependency on a package. You don't know where the package is going to come from. So this is precisely a question you can ask. You can say, I have this requirement that says I need an exporter of the org.foo package. Now, the actual code is a little bit different, but that's really what you're putting in the requirement. You put the requirement in the find providers API, and in this case, there's two bundles that both satisfy the requirement, so you're going to get 2 back, and then, at that point, you can decide yourself as the client of it which one you're going to use. So another example is, let's say you need an extender. Extenders are bundles that do something to other bundles by looking at them. And Blueprint is an extender, DS is an extender. It looks at the bundle to see if there's a particular XML file. If that file is there, it's going to do something with it. But those extenders often are not coupled to the clients by API. So a very good example is, let's say you've written a few Blueprint bundles, you've installed them in the OSGI framework. They all start fine, but nothing happens, right? Because Blueprint may not be there, and that's because there is no package type dependency, and traditionally, I mean, the resolver only looks at those things. So, it can be hard to satisfy these things. So let's say you have such a situation, you say, well, in my deployment, I know that I need a Blueprint extender. You can ask the repository for that question, and in this case, it finds an implementation that has this extender capability specified. All of the specs, by the way, are being updated to define their OSGI extender capability values. So this is kind of a standard capability that you're looking for. And in this case, there's 2 implementations, but only this one matches because that one falls out of the version range. And just finally, another example to show that you can really use anything in that repository. You can really store anything in it. In this case, the client needs a device driver, which is a DLL or a shared library, written for that client's project. And so in here, you were using a custom capability defined by the user. It says, I need a provider of this capability for Linux, x86 64-bit. And you give that to the repository, and there's 2 definitions there. One that is the SO file for Linux, and the other one is the Windows DLL. And in this case, you only get 1 result. Just to show that you can really store any kind of file you want in the repository. You can define your own capabilities, and you can search on those. So it's really a nice and powerful full API. But there was one limitation with it, and the limitation was that the requirements that you could pass into it were limited to a single namespace. So the namespace is the topic that you ask a question about. So what type of packages are being exported is one topic, and what the extender is another topic. There are two different namespaces, but you couldn't combine them. And as you can see in this lovely piece of code down here. You might sometimes have a requirement that is a bit like, I want the exporter of the foo package that also has the Apache license. Yeah, that's a very common thing. You want to combine those two things because your organization only accepts Apache license, for example, as acceptable dependencies. Now, those two things are both expressed as capabilities, but they're in different namespaces. So with repository 1.1, you can now build requirements that span multiple namespaces. And it kind of, here you can see it has some sort of a builder API. You obtain the repository from the service registry. You can find providers on it as before, but now you can get an expression combiner that has a few operations and, or, and not. And then you can put the individual requirements in there. You can kind of build up a complex requirement that, you know, encompasses as many namespaces as you want. And I think it's Carsten's turn again.
Yeah. Nice. Okay, yeah. So let's get into the next topic, which is declarative services. We already have seen the CDI stuff, and we are also making additions to the current declarative services specification. First of all, we are adding these DTOs, so you can get objects representing the current state, like which components are registered through DS and so on. So there's a diagnostic API. You can find out what's going on and what is maybe if a reference is not satisfied for your component and such things. But most importantly, and this is something we have over the time of 1 year, we went back and forth and then completely changed it, I think 3 months ago, to what we have now. You can use annotations for configuring your components. And this might look a little bit strange at first look. You can define your own annotation, like my config in this example here, and this describes the configuration of your component. So my component here takes 3 different properties, a boolean for enabled, a topic, which is a string array, username, and integer for service ranking. So you define this configuration by defining the annotation, and then you can use this annotation simply in the lifecycle methods of DS. So for those familiar with declarative services, you can implement an activate and a deactivate and modified method in your component. And when your component gets activated, this method is called by the framework, by the DS implementation. And as you defined your annotation for the configuration, you will get the configuration, which is maybe stored in the configuration admin, passed into your activate method as a type of this annotation, which is pretty nice, as you don't have to deal now with property names as strings and then maybe cast the value of properties to the actual value you want to have, and you can simply use that as a method. Yeah, there's a question here.
Yeah, how is this aligned to the scopes, the service scopes you mentioned before? I mean, usually when we use the configuration bin for such purposes, there are several service instances with different configurations. And if I have a scope, let's say prototype scope, how it is with it?
Mm-hmm. Okay, yeah, this works perfectly with the service scopes. If you, for example, have different instances of your component, which you would have with service scope prototype, for example, you would also usually have different configurations for each instance, and in different configurations in the configuration admin for each instance. And these configurations are converted into the annotation at runtime and passed into your activate method. So you get different values, actually, finally. Yeah. Yeah, and this makes handling this configuration much easier than before, where you had to deal with all this, with a map of key value pairs and then doing interesting stuff. And of course, you could easily just store this object within your component, and in all your code within your component, you have access to the configuration, which is nicely typed and has the correct values. So this makes the implementation much easier than before. And of course, on the other hand, defining these configuration properties is easy as well. Yes, question?
Why is it an annotation and not just a class? Because this, if you would write test code, I think it's more difficult to...
No, it's actually not. The number one reason for using an annotation, I go back to slides, is that you also can define default values for each property. So if there is no configuration for this component, you can also already define here the default values. And annotation classes are in the end just plain Java classes, so you can just create a mock in your tests like you would do with a normal class. Yes?
This is the counterpart to what you introduced as CDI. So this is the consuming part, and the declarative part was what you talked about?
It's really just an alternative. Like Declarative Services is a long-standing injection technology in OSGI. And this is an announcement to Declarative Services. CDI is another injection model for components. And they can coexist, but they're really alternatives.
Okay. Yeah, so this is this nice new way of configuring your components and defining this. And as I said, you just use it in your lifecycle method, and the implementation of DS takes care of conversion and so on. Especially, sorry, I was on the next slide. Especially it does mapping of names. For example, in Java names you can't use a dot, but most of configuration properties have a dot, like service.ranking or whatever. And so you can we are doing a mapping from an underscore to a dot. That's why I had service underscore ranking in my annotation on the previous slides. And types are automatically converted as well. So if you have an annotation which has an integer field, and for example the configuration in the configuration admin is a string containing a number, then this is automatically converted. And of course we have error handling and so on defined as well. So all is taken care of, hopefully. Yes, and apart from, this was some mapping. Apart from the annotation stuff, as I said, we have this, we support all the service scopes, so prototype is supported as well. We'll see in some minutes an example for that. And we have this diagnostic API with the DTOs and so on, which gives you information about the state. I think these are the most interesting changes to or additions to DS. So let's go to the next topic. As I said in the beginning, these are a lot of different topics, one after the other. So I guess it's a little bit hard to follow, but we try our best. So the HTTP service, which is a very old specification right now, and it finally gets an update which updates the specification to Servlet API 3 and adds Whiteboard support for the different types of services you can have. So you will have Whiteboard support for servlets, for filters, listeners, and so on. And again, we'll have DTOs, which give you the state as transferable objects. But I guess the most interesting part is the whiteboard pattern we have. So for example, if you want to register a servlet, and in this example, I'm using Declarative Services with the annotations defined in DS. Then you can just register your component as a servlet service and define in a property at which path this servlet will be mounted. So for example, in this example, I'm mounting the servlet at /products, /something, whatever is coming next. And the interesting part here is that I'm using the prototype scope here, which is not required to be used, but is suggested. Because if you think of the whiteboard pattern, where your service might be picked up at any time by the HTTP service. And then the HTTP service goes away, and your servlet will be released again, and at a later time, when the HTTP service comes back, will be fetched again. This means that if you have a single object registered in the service registry, that the servlet will get, that the init method of that servlet will be called several times, potentially, and the destroy method as well. The implementation must be aware of that. So either you have your implementation being aware of that, or you just use the prototype scope, making sure that you have a fresh instance for each usage, which makes it, again, much easier. So you can just use existing code, use the prototype scope, and you're done. And then if you want to register a filter, it looks basically the same. You register it as a filter service, specify, for example, the pattern under which this filter is called for requests. Or you could also define for which servlets the filter is called. So basically you have the same possibilities as you have with the web.xml in a web application. And then you can implement your filter, and it's picked up by the whiteboard pattern and applied whenever such requests come in. And then we have the same support for listeners. You just register the listener as a service with their interface they are implementing. You can also register error pages or resources through the whiteboard. So everything is covered by the whiteboard pattern in the new specification. And to make it more complicated, you can also have shared HTTP contexts if you ever have the need just to mention that. And in the case you have, in your installation, you have several HTTP services running, which some people do, then you can also target to which HTTP service your servlet should be bound. This can also be done by some registration properties through the whiteboard pattern. So it's all taken care of, well-defined, and done there. And I think with that, we're going to the cloud.
Yeah. Okay, so let's talk a little bit about what we're doing with regard to cloud at OSGI. Spoke a bit about that last year. I'm not sure if everybody was in the room at the time. And things have moved on in the meantime, in that we have started to write an RC about this. So it's a little bit too big for the screen, but this is kind of a little bit about what many PaaS offerings are, or how they're structured today. Many PaaS offerings give you a deployment platform of some sort where you can deploy your application. And if you want to scale up because you have an increased load, you deploy more duplicates of your application. I mean, that's a very common pattern that you see. In many cases, those applications can communicate in some way by having a shared database that they run underneath. So, let's have a look. Yeah, what we're currently has the working title OSGI Cloud Ecosystems is a little bit different in that it gives you a unified logical PaaS layer where there's actually many different components that work together to provide a logical function. So they're not pure duplicates. There's kind of a variety of components being active in this PaaS layer that may or may not be spread across many different machines, virtual machines. That's all kind of possible. There's a lot of flexibility there too. So in such a cloud ecosystem, you have many OSGI frameworks hosting a variety of deployments, and all those deployments together provide your application. And they're not just a bunch of replicas, they're a collection of different nodes that have different roles, and although some of them might actually be replicas. I mean, in some cases you do have to put replicas in, but you know, in other cases not. So you can really precisely tune how you want to scale your application up and down. So obviously the load of your application varies over time, and so does your application. The OSGI Cloud Ecosystems idea allows you to to basically change your topology and your configuration, the number of nodes, depending on the load and the requirements of your application. So you have a lot of control. So to do that, you really need information. That's the thing that you need. You need to know what nodes are available. You need to easily be able to react to changes. Nodes might die, loads might increase or drop. Maybe even because it's OSGI, you might be deploying some new functionality. Maybe the requirements of your application even change at runtime. That's highly possible. So you need that information. And then secondly, you need a provision capability so that as soon as you have that information, you can start doing something about it. So that's what you need. And you need some remote invocation infrastructure inside your cloud system so that the nodes, the various nodes that are kind of in there, can easily communicate with each other. Now, you may or may not use that for your business logic. In some cases, it's perfectly fine to use a standard RPC-style remote invocation mechanism for your business logic. In other cases, you might want to use distributed events or streams. And in those cases, the remote invocation infrastructure is still very handy in setting up those streams and getting those channels configured. So that's really what RFC 183 Cloud Ecosystems is about. It defines an OSGI service, which is called the Framework Node Status Service. And that's an OSGI service, a remote service, that provides information about all the OSGI frameworks that are in your cloud system. So every other node that is in your cloud system can see all the other ones that are there. But it's not being made visible to the outside world. It's only within your cloud, the bunch of cloud nodes that kind of form together your cloud system. And it provides information such as the host name and the IP address of that node, the actual physical location where it's running, for example, the country, which is for some application really, really useful. There might be legal requirements to run particular types of application within a certain jurisdiction. So that information is there. It gives you information about the OSGI framework version, the Java version that's running, and it gives you a REST management URL so you can actually start doing provisioning. Those pieces are roughly, they're a little bit static information. There's also more dynamic information available, like the amount of memory, the amount of disk space. Maybe you have some sort of a load factor that you want to make available, so that when you do some provisioning action, you give the machine with the lowest load factor some extra work to do. And you can also add your own custom method to it. So just to give you an idea about what's there, it's a bit too big. But this is taken from the RFC. This is just this is just the properties, the service registration properties on the Framework Node Status service. And you can see there's a property where you can read the host, and there's actually two properties for it. There's an internal host and a non-internal host, the external one. In many cloud systems, VMs have two IP addresses. One that is the one that you use on the inside, and the other one that is the one that is used by the people on the outside. So there's a distinction made for that. There's information about the type of infrastructure that is underneath. Maybe it's Amazon, maybe it's Azure, maybe it's Rackspace, and an associated version. So in some cases, if your application uses cloud-specific stuff, now obviously we always like to, say that it's better to use standard APIs that are portable across everything. In some cases, you really want to be able to use some cloud-specific stuff. That's still possible, and the nice thing here is that the metadata is available. You know what cloud you're on, so you can use that as part of your provisioning to maybe deploy a cloud-specific driver for various platforms, and you might have different drivers for different platforms. There's some standards-based location properties that are available, country code, a more specified location code, which is also an ISO specification, which can, define a county or even a city. That's also kind of available. And there's another property that maps more to how cloud providers express it themselves. Like, for example, Amazon has US East, US West. That information is also available. And here is the This is the REST API URLs. I'll talk about that in the next slide. And the OSGI framework and Java runtime metadata. So, as I said, you can also add your own properties to this set, but this is the standard set of properties that you get from the framework node status. And it's a lot of information that can be very useful when you deploy and when you provision your system in the cloud. Okay, so this is a little bit of a sidetrack slide about RFC 182, which is about the REST API. It's for the OSGI framework. The REST API is really a remote management API which uses the REST protocol under the hood. There's already a number of OSGI specs that are about remote management. There's a JMX spec, there's DMT admin. They all had their use cases, but they're not necessarily always that useful in a cloud context. Like I know from experience that getting remote JMX to work in the cloud is actually not very easy because of firewalls and limitations to the number of ports that you can open. REST is brilliant. It's really simple. It's HTTP based. And so that's what Jan Rellemeyer at IBM has been driving. And the REST API basically works like this. You have a URL which you can obtain from the framework node status service, and with that URL you can create a REST client and start managing your framework. And there's also JavaScript client-side API being defined for it. So that works great with the framework node status. As you can see in this example, this is just, it's just a service tracker. Obviously everybody would use DS or CDI or Blueprint, but I just wanted to keep it simple. I've got a service tracker that has a callback with adding service. There's a new node in my system. I'm getting a callback. And at this point, I can now read the property that gives me the management URL. I can create my management client, and I can start, deploying stuff to it. Typically, in the piece that is white here, you would have some logic that decides what you want to deploy on it. That's typically application specific. But this is how easy it is to control that node. There's some additional ideas in RFC 183 that I just wanted to mention. It defines a new remote services configuration type called OSGI.config-type.ecosystem. And there are some special characteristics with this configuration type. The remote services specs allow you to define your own configuration types. This would be a standard configuration type that has two properties associated with it. First of all, it really crisply defines the data types that it supports across remote invocation. So you really know whether your API is going to work in advance or not. So that's one thing, because not every data type is supportable across a remote invocation, right? You have typically pass-by-value semantics. If you want to send an AWT class across the remote API, it doesn't work, right? Everybody would expect that. But, this config type clearly defines what data types are supported. And it's like simple types, arrays, collections, maps, and that's pretty much it. And the other thing about it is that it gives all the services that are remote using that configuration type visibility within your cloud system, but not on the outside. So you have an easy kind of way of working together, but you also have a boundary around it which gives you some security effectively. Another idea in there is the ability to intercept remote service calls. So that would allow you to give each remote client a different service implementation. So you might have different subscriptions depending on the client. You might, you have a client that uses the free connection, whereas another client is maybe your premium subscriber, and maybe you want to give them different implementations to service their requests. So this is a little bit like a service factory, but then for remote clients. It allows you it gives you control with regard to what you give to service a remote request. And you can also do some additional things with it. You can do quota control, you can do invocation counting, you can do billing with this thing as well. So it's just a handy feature that is very typical in a remote service scenario. And then finally, another idea that is in there is the ability to provide additional metadata about remote services. And this was one of the requirements that about a year and a half ago came from a workshop at Eclipse in Reston, I think, where basically people are saying if you have remote services, they might fail for reasons that are different than local services. I mean, maybe if it's a for pay service, maybe your credit card expired. Or maybe if it's a remote service, it might go down over the weekend. You want to inform people ahead of time that it is going down. So that's more like a warning, whereas the first one is a failure. And RFC 183 is kind of talks about some ideas around making this metadata available in a standard format to clients, so you can be prepared if something goes down, and it also gives you a reason why your remote service isn't there anymore, so you can react to it intelligently. So the current OSGI cloud work really gives you a baseline to build fluid cloud systems where things can move around and things are very kind of dynamic. So it is a baseline to allow you to build something like that. And another benefit is really because this is defined as a specification, it gives you portability across implementers of such a specification. So it makes it easier for users to migrate from one cloud to another, because if they both implement the specification, you don't have to change your APIs. You can just move your bundles from one to another. And it should also make it easier for people who want to use hybrid clouds, where there's a combination of cloud vendors, or maybe partly internal and partly external. So that's all goodness. Another thing that is kind of a nice side effect of using OSGI here is that in OSGI you can repurpose your framework. You can uninstall bundles and add new ones without having to restart it. The OSGI dynamics allow you to do that. And you can also, sometimes you may want to restart it. That's up to the use case. But at least you don't have to resend the whole VM image across again, and that might save you a lot of bandwidth as well, and in some cases that might save you money. So that's a nice benefit. And really, as a developer, you just use OSGI services to deal with your cloud nodes, which is just very nice. So you use whatever technology you like best, Blueprint, Declarative Services, CDI, Service Trackers, iPojo. It all works with OSGI services, so you can continue to use whatever is your favorite of those lists. Okay. Next topic, context switch. Okay, this is an entirely different topic, but it's another spec that's being worked on. It's called portable Java contracts. So before I go into what that actually means, I'm going to briefly talk about semantic versioning. Now, this is only one slide about semantic versioning. There's actually another talk, I think tomorrow, by Ferry, who's spending half an hour about semantic versions. But just really briefly, semantic versioning is a versioning policy defined by OSGI about exported packages. So most people in the room probably know OSGI versions look like this. They have three numerical parts: major, minor, micro, and then they have a qualifier, which is basically string. And semantic versioning defines how you update that version for a package if you make an update. So it's really very simple, and this is effectively all there's to it. If you make a change to this package, and that change is really just a fix or a patch, a bug fix or something like that, you increment the micro version. So that says the contract's still the same, but this is better than the previous one. It's a bug fix. When you extend the API, so maybe you add a new method to an existing interface, maybe you add a whole new interface, something like that, clients are not affected because the clients use the old API interface. They can still invoke all of the existing methods. They will never invoke the new method. Things will still work for clients, but implementers of the API obviously have to do work because they have to implement this new method, they have to implement this new interface. So in that case, you update the minor version. And then finally, if you've completely broken your API, then you update your major version, and that way is a way to signal to the clients that they have to do work if they want to upgrade to your new version of the package. So that's really all there is to it. It's specifically for packages. Sometimes it's also used for bundles, but that's really up to individual choice. You don't necessarily have to use it for bundle versions. So that's all very nice, but the problem with that is that not everybody uses semantic versioning, and specifically APIs that come out of the JCP, JSR-defined APIs, do not use the semantic versioning. And a very typical example here is Servlet 3. It's called Servlet 3, but it's actually backward compatible with Servlet 2.5. You might think, what's the big deal? Well, the big deal is that it becomes unclear what the version of the JavaEE Servlet package is. Is it 2.6 because it's backward compatible? Or is it 3.0 because that's the version of the spec? And different projects that provided this API made different choices in assigning that version. And the net effect of it was that it became impossible to write, or very hard, to write a client bundle that uses this API in a portable manner. Because if you had to define your import range on your client bundle, it became dependent on where you were going to run it to say what versions you were putting on that. So that's the problem. The fact that these projects have their own versioning schemes made it hard to write portable client bundles. Now, that is being addressed by RFC 180, which is called Portable Java Contracts. And this slide really describes how you use it from a client point of view. What you do is you require a new capability, which is in the spec. It's called OSGI.contracts. And you, for example, if you use the Servlet API, you require the Java Servlet contract. And the version you use in that case is the marketing or the spec version. So there's no disagreement about what version is being used. It's not the semantic version, it's the marketing version. So here I say, I require the OSGI contract capability for Java Servlet in version 3. And additionally, I obviously still need to use the import package to bring the packages in. But interestingly, I leave the versions out there. So it's a little bit different than what OSGI typically tries to advocate, but this at least allows you to write portable bundles for these packages that come out of the JCP. That's mainly where it's going to be used. The RFC itself defines all the various contract names. It's going to be put on a web page and maintained, with the JSR updates as well. So you can, if you want to know whether typically it's about Java X something packages, right? You can just go to that web page, check your package, see what the contract name is, and then import it in a portable way. And with that,
it's me again, yeah. Which I think is more or less the least topic. Oh, there's one more. Okay. Anyway, in addition to what David said about versioning and semantic versioning, we also added some of the some more annotations to the specification. And those of you who are using BND or BND tools might probably already know these annotations. Now they are becoming part of the official specification. So for one, we have the add version annotation, which allows you to define the version for your package. So if you have a package-info.java file, you add this annotation in there, define the version, and you are done. And then the tooling can pick up this information and create the package exports for your bundle. And then there are two other annotations defining the types of API. You define the provider type and consumer type. For example, if you think of the event admin specification, which defines an event admin service and event handlers, then the event admin service is a provider type. As this service is provided to you, you're just using it, you're never implementing this interface yourself. And the event handler interfaces, those are the things you implement and register, and those will be marked with consumer type. And these annotations then allow you to define or find out how to increment the version of your package, depending on how this interface, for example, is marked. For example, if you add new methods to a provider type interface, this is just extending API, as David has shown on one of the previous slides, so you can just increment the minor version. But if you add new methods to a consumer type, then this breaks all clients implementing this interface, so you usually should update the major version of your package. And tooling can find out these things, and on the other hand also generate the import ranges for the packages correctly and so on. So it's very, very nice, and it helps you in dealing with that. For you as a provider of an API, you just mark your interfaces with that and let the tooling do the rest. And then it's back to David again.
All right. Okay, we're nearly at the end. Just wanted to mention a few other specs that are being updated. There's really only minor changes that are being made to it, but I think it'd be good to mention it. The blueprint specification is being updated to support non-damping. I mean, damping was one of the features that set Blueprint apart from DS, in that, you know, it was great for demos. I'm not sure if everybody's aware of damping, but, you know, basically it means that if you have a service that is injected in your Blueprint component, you take the service away, at that point the service is gone. If somebody makes an invocation on that reference, which is still there because it's injected as a proxy, Blueprint would sit around for 5 minutes to see if you wanted to kind of register an alternative. So that came out of the Spring background that influenced Blueprint a lot, and it was great for demos, but in production scenarios wasn't really that useful. So, you know, Blueprint is being updated to also, I mean, it's not being taken out, but it now also supports non-damped service references, so they fail fast effectively. Blueprint also has a concept called grace period, which is about, you know, the time that it kind of allows for all the services to kind of appear so that it can be injected. It also contains some extensions to that, mainly around the fact that if services never came up, then in the previous version of Blueprint it would enter what was called the zombie state. And that wasn't always very useful because it was kind of an unrecoverable state that's being addressed as well. And it contains many small fixes as well. Remote service admin, one of the two remote services specifications, is being updated to support modification of remote services. Not sure if everybody's fully familiar with the OSGI remote services specs, but basically what they allow you to do is that you take an OSGI service, you add a few properties to it, service registration properties, and all of a sudden it's available remotely, so accessible across JVMs, which is very nice. But there was one thing that was initially deliberately actually left out, in that if you change the service registration property of your remote service, the remote endpoint was actually unregistered and re-registered. So there was a service taken away and another one added, which could be on the same address, but still it was that action. And in practice, that didn't turn out to be that to be that useful in some cases, because if there were clients looking for services and reacting to services going away because they might want to fail over to another one, a situation like this would cause a lot of volatility in the system, even though you might only be adding one property to the service registration. So that's being addressed in that now modifications can be sent across without actually taking away the remote service. And then finally, a subsystem is being updated. And one feature that I wanted to kind of lift out of those updates is the deployment manifest. Now, subsystems 1.0, again, is another fairly new spec. It came out in 2012, last year, and it basically allows you to create a whole set of bundles together under one name. So you can have, your application subsystem, and you might say, okay, my application is these 3 root bundles and all of their dependencies. And a subsystems has a lot of different ways in which you can bundle that. You can put all the bundles in an ESA file, which is effectively a zip file. Or you could say, I'm only going to put a descriptor in that zip file, and I'm going to resolve everything from from a repository, or you could do something in between. You could say, I put my root bundles, that is really the core of my application, in the zip file, but I want to resolve the rest from the repository. So there's a lot of flexibility there, which was really cool. It really gave you a way of, handing someone an OSGI application as one file, which they could deploy. And one of the features that it has is this deployment manifest. So subsystems are they allow you to express dependencies, transitive dependencies, using version ranges. So you can say, I need the log servers to run this application between version 1 and 2. But maybe you actually did a QA phase where you ran a particular version of a bundle representing the log service. And in the QA phase, that was all working fine. When people are going to deploy this for real now, you want them to run the exact same log service as you did your QA with. Now you can actually encode that in the deployment manifest. So the deployment manifest overrides the subsystem manifest, which might have these ranges. So that's a very cool feature. It gives you a lot of predictability. But initially, it actually had to be part of the zip file. And I mean, that's not always that practical. With Subsystems 1.1, you can also provide this manifest now as a separate argument to the deployment API. So you can provide it outside of the ESA file. And then finally, I didn't put it on this slide, but there's another spec that was being talked about in the hour before this, which is developed in the residential expert group, called the device abstraction layer, which is really about abstracting over the various Internet of Things type protocols like Zigbee, Z-Wave, N-Ocean, possibly other ones, Bluetooth maybe, MQTT possibly. And basically it provides an OSGI abstraction over various devices, and that the programming model stays the same across the various underlying technologies. Is that correct, Dimitar?
Yes.
Yeah. So that's another spec that's being worked on in OSGI. I didn't make the slide, but just wanted to mention it. Where can I get it? You can get it at GitHub. One of the things that OSGI changed recently is they made the change that all of the RFPs and RFCs are now visible to everyone live. So if someone makes a commit to an RFC, it's instantly visible at that location. That's where they all are. You can just read what they are. You can provide feedback. It contains instructions how you provide feedback through Bugzilla. Or obviously you can join the OSGI Alliance and provide direct feedback that way as well. That's always possible too. Everybody's welcome. And most of the work that Carsten and I talked about is aimed at the core enterprise release R6, which we are trying to do next year. Fingers crossed. And but some work is aimed at enterprise R7, especially the cloud ecosystem spec is not going to make R6. That's probably going to be in 2015. That needs a little bit more bake time. But most of the other things that we spoke about are aimed at core enterprise R6. Questions? No questions. So one thing that is probably worth adding is that many of the things that we talked about are ideas that are already implemented in various open source projects that will probably become the reference implementation. In many cases they are done in Apache Arias. Sometimes they're done elsewhere. Or another Apache projects, Apache Felix is another place where a lot of this work is actually happening. So if you see something and you think, this is really cool, I want to play with it, the reference implementations are already in most cases updated. The repository is in JBoss at GitHub, so that's another place. If you're unsure where to go, I didn't put a link in, but there's a Wikipedia, just an ordinary Wikipedia page called OSGI Specification Implementations, and it contains a list of all the projects that kind of are part of the OSGI, that implement an OSGI spec in one way or another. So it usually gives you a couple of alternatives to